What is a hyperbola? A hyperbola is a conic section formed by intersecting a right circular cone with a plane at an angle such that both halves of the plane are intersected. We can see this in the figure below. The blue cone is our right circular cone. There's a gray plane intersecting that cone, and we can see in orange those two sections collectively are the hyperbola. The two separate unbounded curves that form a hyperbola are mirror images of each other. And again, same image, we can see this again. These two curves, which are unbounded and separate, form a hyperbola. Another definition we can use is that a hyperbola is the set of all points, x, y, in a plane such that the difference of the distances between x, y, and the foci is a positive constant. Every hyperbola has two axes of symmetry. The transverse axis is a line segment that passes through the center of the hyperbola and has vertices at its endpoints. We can see this in the picture to the right. This red line, so here's where the label is. We follow the arrow down and we see that this red line right here is our transverse axis. This black point is the center of the hyperbola, and right here we have one vertex and the other. Additionally, the foci lie on the line that contains the transverse axis. So in the picture to the right, that is the x-axis. That is the line that contains the transverse axis. So the foci lie along the line, and the foci are here and here, inside the curves of that hyperbola. The second axis of symmetry is called the conjugate axis. This is always perpendicular to the transverse axis and has the covertices as its endpoints. So we can see again in our figure we have the label for the conjugate axis. Follow that arrow down, we see it's this blue line that I'm boxing right now. Passes through the center, that black dot, and we have 1, 2 covertices. The center of the hyperbola is the midpoint of both the transverse and conjugate axes. This is where they intersect. So let's take a look. This black dot is our center, the red line is the transverse, the blue line is the conjugate. We see that they do indeed intersect at that point at 90-degree angles to each other. And we can tell from this picture, because it's drawn accurately, that that is the midpoint of those two regions. The left-hand side of the transverse axis and the right-hand side of that are split evenly by this midpoint. And the same, the conjugate axis is split in half by the center. Every hyperbola has two asymptotes that also pass through the center. And as the hyperbola recedes from the center, its branches approach the asymptotes. So we'll take a look at that. The orange dotted line in the picture are our two asymptotes. We can see they pass through the center, that black point that I have circled. And we see here that as the hyperbola recedes, these blue curves that represent the hyperbola, as it recedes, they get closer and closer and closer to that asymptote, but they'll never quite touch it. The last piece of a hyperbola is the central rectangle. It's centered at the origin in our picture with sides that pass through each vertex and covertex. Now, if your hyperbola is not centered at the origin, that central rectangle will be centered at your center of the hyperbola. We see that in green in the picture on the right. We notice it is indeed passing through both vertices and both covertices.